Suppose c of x is equal to x cubed minus 22x squared plus 30,000x, and that is the cost of manufacturing x items. We call that the total cost function. Find a production level that will minimize the average cost per item. Now, be careful here. We're not minimizing cost, we're minimizing the average cost. So the question is, what is average cost? We use C bar of x to stand for average cost, and the average cost is the total cost divided by x. In other words, the total cost of producing x units divided by the number of units. And it's just like averaging anything else. If you had a bunch of test grades and you wanted to find your average, you total them and then divide by how many tests there were. So same idea, the average cost is the total cost divided by how many units. Of course here, c of x is this polynomial x cubed minus 22x squared plus 30,000x divided by x. Now notice there's an x and everything in the numerator. I can factor the x out and cancel it, or think about the x going into each term individually. Either way, when you take x into x cubed, you get x squared minus 22. When x goes into x squared, you're left with x plus, and when x goes into x here, you're just left with the 30,000. So this is the average cost function, and that's what you want to minimize. You're not minimizing cost, you're minimizing average cost. If you're minimizing it, that's what you want to take the derivative of. So now we want to take the derivative of the average cost. Now think about that and make sure you've got it. You're not minimizing cost, you're minimizing average cost, so that's the function that you take the derivative of. And that gives you 2x minus 22. Of course, the next thing you want to do is set that derivative equal to 0. So you get 2x minus 22 equals 0, which means 2x is equal to 22, which means x is equal to 11. You want to make sure that really is a minimum by using probably the first derivative test. You take a number smaller than 11 to the derivative of the average cost function here, because you're looking at the slope. If you put, say, for instance, 10 into the derivative, you get 2 times 10 is 20. 20 minus 22 is negative 2. So that function is decreasing to the left. Then you take a number bigger than 11, say 12, plug it in. You get 12 times 2 is 24. 24 minus 22 is positive 2. So even though you're dealing with the average cost function, when you're looking at slopes, you're dealing with the derivative of it. So now you're looking at the derivative. So you take a number to the left, plug it in, you get a negative. Take a number to the right of the critical number, plug it in, you get a positive. That verifies that this is a minimum. You pretty much knew it was going to be, because that's what they were asking for in the problem, but technically you should be sure you really do have a minimum. So the answer to the question is producing 11 units will minimize average cost.